Hello everyone, welcome to ECE111 lessons. So today we are going to start a new topic which is called as VDR and CDR, voltage division rule and current division rule. So how we use these two rules for voltage division and current division for solving any circuit. So let us to start with, first let us consider or determine how we find out the current division formula. So to start with, here we have written as parallel resistors and current division, because for current division to apply we have to have the circuit in the format of parallel combinations. So in current division we'll be determining how the current gets divided into different resistors or different parallel circuits. So to start with, we have considered a circuit here where we have a voltage source V and two parallel resistors R1 and R2. So here, if suppose let us consider this current to be I, the input current which is flowing from the source, and it is getting divided into two currents, suppose I1 and I2. So in such case, according to Ohm's law, what will be the voltage across resistor R1? Suppose this is, we are calling it as VR1, this is we are calling it as VR2. These are the potential drops. So VR1 will be equals to I1 R1 and VR2 is equals to I2 R2, right? But as we know, there are no any other resistors in between, and these two are parallel combinations. So the voltage across the resistors will remain same. So that means V equals to VR1 equals to VR2, which means the value of I1 R1 equals to I2 R2 equals to the voltage V. Okay. So now if we apply KCL across this node, then the KCL will be I1, incoming current is I1, outgoing currents are I1 and I2. Incoming current is I and the outgoing currents are I1 and I2. So we can write down the KCL as I equals to I1 plus I2, right? So from these equations, what we can write about I1 and I2? So in place of I1 we can write as V divided by R1, right? And this will be V divided by R2. Okay, so if we take V as common, so it will be 1 by R1 plus 1 by R2. Okay, again what we know is the current I is also given by V divided by the equivalent resistance, right? So in this case, what is our equivalent resistance is determined by 1 by R equivalent. As we know, this is a parallel combination, so 1 by R1 plus 1 by R2, or we can also write it as R equivalent equals to R1 R2 divided by R1 plus R2, right? So now what we can write here is, in place of let me scroll down like this. Okay, so let us consider here, so V equals to I divided by V equals to I into R. So this is also equals to R1 R2 divided by R1 plus R2, right? As we have already determined this, R equivalent equals to R1 R2 divided by R1 plus R2. Now what is our I1? I1 we have determined as V divided by R1. So now here in place of V we can write down this equation. So it will be 1 by R1 into R1 R2 whole divided by R1 plus R2. I am putting I here. Okay, so In this equation, R1 and R1 will get cancelled. So what we get, I1 as equals to R2 divided by R1 plus R2 into I. Similarly, I2 will be equals to R1 divided by R1 plus R2 into I. Okay, so these are the corresponding values of I1 and I2 when we are considering parallel resistance. Okay, so now this is the current division formula. Now if we increase the same circuit into multiple resistors, that means suppose let us consider our input current as I, and then we have resistances. You can combine the resistances like this. Okay, so suppose this is a resistance in between, and then this is the final resistor. So this is suppose current I, this is suppose R1, R2, R3, like this, so on up to Rn. Okay, now this is suppose the intermediate resistor called Rx. Okay, so now if we look at the formula, what we have got here, what is the value of current I1? Current I1 is nothing but it is the resistance in the other branch divided by the total resistance multiplied by the input current. Similarly, current I2 equals to the resistance in the other branch. So what do I mean by other branch here? So you can see here, this is your I2. So I2 is this current, right, where we have resistance R2. So I am referring to as other branch means the other branch will be R1 where current I1 is flowing. So the other branch divided by total multiplied by the input current. Okay, similarly I1 equals to the other branch divided by total multiplied by I. Okay, so now if we extend this into this circuit, then what will be Ix? So we can see here, this can be called as I1, this can be called as I2, this current can be called as I3. So like this current will be Ix and final current will be In, right? So what will be Ix current? So Ix current will be nothing but, as I have mentioned just now, that it should be the other resistance. So if I have to convert this whole circuit into the simpler circuit like this, then what we can consider it here? So it can be considered like this. So this is I and this is my suppose Rx, and this is suppose another resistor RT. So what is RT here? RT is parallel combination of R1, R2, R3 like this up to Rn excluding Rx, right? So we can represent all the resistors together by a resistor which is called as RT, which is nothing but the equivalent resistance. So R1 parallel to R2 parallel to R3 up to Rn excluding Rx, because Rx we are considering here. Okay, and the input current is I. So now what will be my current equation? My current equation will be the other resistance is RT divided by total resistance, that is your Rx plus RT, multiplied by input current, which is I. So I am just following this consideration, and this is my general equation for current division rule. Okay, so what is it? So the current in any branch is equals to the ratio of resistances, where we have the resistance which is not, we are not considering. That means suppose we are determining current across Rx, so we will be considering the other resistance which is nothing but RT. So RT divided by Rx plus RT multiplied by I. So this is the general definition of current division rule. So we can use this for solving any circuit by using this formula. So whenever we are doing or considering this type of equations, that is your CDR, current division rule, then we have to minimize the circuit into this format first, and then we can directly apply or determine the current. For example, suppose if you want to determine the current across the other branch, so the other branch will be Rx divided by Rx plus RT into I. Okay, so I hope you have understood. So mainly we will be following this formula, and how this formula we have to write it as the other branches divided by the total multiplied by your current. Okay, so now let us move into series voltage and series resistor and voltage division. So I have already kept it ready here. So as you can see here, this is your series resistance. R1 and R2 are in series. This is your input voltage V, and current is flowing across it is I. So what will be V1? V1 is nothing but the voltage drop across R1, which is IR1. What will be V2? V2 will be the voltage drop across R2, which is IR2. Okay, so now if we apply KVL equation, as we already know, this will be voltage drop minus this, right? So it will be V minus IR1 minus IR2 equals to 0. So from here we can determine V equals to IR1 plus R2. So current will be voltage divided by R1 plus R2, right? Again, like your previous case, in case of your CDR, whatever we consider, so the total voltage V equals to I into R equivalent, right? So using this formula, where R equivalent is nothing but combination of R1 and R2, the series combination, here we have all the resistance in series, so it will be R1 plus R2. Okay, so now if we determine the voltage V1, which is nothing but IR1, where I is replaced by V divided by R2, R1 plus R2. So I is replaced by V divided by R1 plus R2 into R1. So the formula will be R1 divided by R1 plus R2 into V. Similarly for V2, it will be R2 divided by R1 plus R2 into V. Now, like your current division rule, similarly if we extend this circuit into this circuit, where we have, this is resistance R1, R2, this is Rn, and this is in between Rx, and we are determining what is will be your Vx. This is V1, this is V2, okay, and this is Vn, and input is V. So according to this, the whole circuit can be converted into a simple circuit containing two resistances, where one will be Vx, second one will be, suppose Vn, right? So this is your input V. So as per this formula, what we can write, so let me change the color so that it will be easy to understand. So what we can write is Vx equals to Rx divided by Rx plus, sorry, this should, I have not mentioned, this is your Rx, this is your Rn, these are voltage drops, right? So Rx divided by Rx plus Rn into V. Similarly Vn equals to Rn divided by Rx plus Rn into V, right? So what is the logic here? Here the logic is, wherever we are determining the voltage, that resistance divided by the total resistance. So this is your Rx divided by Rx plus Rn. Okay. So similarly Vn will be Rn divided by Rx plus Rn. Okay. So I hope you have understood how we are using voltage division and current division rule. So let us consider a numerical. Consider a quick numerical, and let's see how we can solve this. So for simple circuits like this, there is no issue. Suppose this is 10 volt, this is suppose 2 ohm, this is suppose 3 ohm. Okay, so what will be the voltage V1 and V2? So as per the formula, V1 equals to the resistance where we are calculating, that is 2 divided by 2 plus 3 into 10. This is the V1. Similarly, what is the V2? This equals to 2 by 5 into 10. So this is 4 volt. And similarly, this will be 3 divided by 2 plus 3 into 10 is equals to 3 by 5 into 10. Right? So the voltage drop V1 is 4 volts and V2 is 6 volts. So there is no issue in this simple circuits. Now suppose we are considering another circuit which is not in series. So suppose we are considering this circuit. So this circuit is not in series. So this is, suppose let's consider easier value. Easier value means so that we can easily calculate 3. This is suppose 4 ohm. Okay. So we have to determine the voltages in the circuit. That means we will be requiring 4 voltages, right? What are these 4 voltages? So let us consider voltage across 1 ohm. So what will be the voltage across 1 ohm? Will be nothing but 1 divided by 1 plus what will be the remaining? Remaining is the equivalent resistance. So equivalent resistance means 2 parallel to 3. 2 and 3 are in series, and that is parallel to 4. So like this we will be having this type of circuit, right? Now this will be 1 ohm and remaining will be, this is 5. 5 parallel to 4 is 5 plus 4. So if we calculate this is 20 divided by 9. So 20 divided by 9 comes out to be 2.22. So this is coming as 2.22 ohm. So this will be 2.22 ohm multiplied by 10. Okay. So whatever be the value, it is our answer. Okay, let us calculate. It will not take much time. So this is 1 divided by 3.22 is equals to this much multiplied by 10 is 3.10, right? So the remaining 2.22 ohm will be, means this total resistance will be, or the voltage drop across this will be how much? So it will be 2.22 divided by 1 plus 2.22 into 10, which will be 2.22 divided by 3.22 equals to this much multiplied by 10 should be 6.89, right? So if we add this two, we will be getting nearly 10 volts, right? So this will be 9, this is 9, this is 9. So after adding, this will become 9.99, which is nothing but 10 volts. Okay. Now whatever we have got, that means this voltage 6.89 volt and this was your 3.1 volt. So this 6.89 volt is getting divided into these two, right? So this 6.89 volt will behave as a source for these two resistances. So what will be the voltage across 2 ohm? So voltage across 2 ohm will be 2 divided by 2 plus 3 multiplied by 6.89. Okay. Similarly, across 3 ohm will be 3 divided by 2 plus 3 into 6.89, right? But how we have done this? So the resistance, wherever we will calculate, that is your 2 divided by both the resistance 2 plus 3 into the total voltage. Total voltage is 6.89 across this branch. So this will be whatever we get, that is our answer. Next, for 3 ohm, the resistance wherever we are calculating, that is 3 divided by both the resistances, addition of both the resistances multiplied by 6.89 volt. So whatever we get, that is our answer. Okay, so like this we can solve any circuits using voltage division rule. So this is quite interesting, right? So similarly, now if we consider current division rule, that is far more interesting. So let us consider a simple circuit. So let us consider this circuit, then draw the sources and resistors. Let me increase the size a little bit. So suppose we are directly considering current source, then no need of determining R equivalent or determine the value from voltage. So suppose this is 10 ampere, this is current, this is resistance, suppose 1 ohm, this is resistance 2 ohm, this is suppose resistance 3 ohm. Okay, so this is current I divided into I1, I2 and I3. Now we have to determine the current using current division rule. So let us start. So what will be the current I1? So for current I1 we can write the circuit like this. This is 1 ohm and this is resistance combination of 2 ohm and 3 ohm, right? That means parallel combination of these two, which is nothing but 2 into 3 divided by 2 plus 3, right? And this is 10 ampere. So we can write down the equation like this, right? So suppose this name, let us name it as R1, R2, R3, so that our equations will be easier to understand. So what will be I1? I1 is the resistance other than where we are considering. That means other two resistance means this R23 should be the resistance. So it will be R23 divided by the remaining resistance R23 plus R1 multiplied by the total current, which is 10 ampere. So here R23 is 2 into 3 divided by 2 plus 3. Okay, so this is how we determine I1. Next I2 will be, now here we have to determine, so these two resistance we have to combine, R1 and R3. So it will be R31, parallel combination of R31 divided by R2 plus R31 multiplied by 10, where R31 is, R3 is 3, R1 is 1 divided by 3 plus 1. Okay, so whatever value we get, we can directly put it here. Next, third case, I3 equals to, so it will be obviously other than 3, so it will be R12, so divided by R3 plus R12 into 10, so where R12 equals to how much? 1 into 2 divided by 1 plus 2. So if we put these values here, we will get the value of I1, I2 and I3. Okay, so this is quite easy, right? So now a slight complication may arise if we, in the same circuit, suppose if we are putting a resistance here. Now what will be the changes? Suppose we are putting a resistance here of suppose 4 ohm. Now in this case our input current is okay, there is no issue with this, so it will remain as 10 ampere only, right? Now what will happen? Whatever 10 ampere comes here, that will get divided into I1 and this current, right? First 10 ampere will get divided into I1 and this current. Suppose this is Ix, then this Ix will get divided into I2 and I3. So we have to determine another current which is called as your Ix. Okay. So in this case, your for I1, calculating I1, there will be again another equation where we have R2 and R3 in parallel in series with Rx. So suppose we call it as R23x divided by R1 plus R23x multiplied by 10. Okay, let me write down the x like this so that you don't get confused. So where R23x is what? R23x is nothing but parallel combination of R2 parallel to R3 and then series with Rx. Okay, so once we get this, we'll get the value of I1. Next, what will be the value of Ix? So Ix value is nothing but R1 divided by R1 plus R23x into 10, right? So you can determine the value of I1 and Ix, right? Now this Ix value will behave as input to I2 and I3, right? So the remaining equations are similar. That means your value of I2 will be equals to, it will be R3, other resistance is R3 divided by R2 plus R3 into Ix, because now Ix is our input, right? Ix current is our input. So similarly I3 equals to, this will be R2 divided by R2 plus R3 into Ix. Okay, so you put down the values, you will get the answer. So is it understood? So if all the resistance are in parallel, then there is no issue. We can directly write down the equations like this. If we have a series resistance in between, then the equation will be slightly different. Why the equation? Actually the equation is same. Our consideration will be slightly different, that we have to determine the remaining current also. That means in this case we have to determine I1 first, then we will determine this Ix, because this Ix is getting divided into I2 and I3. Okay, so this is as simple as that. So you just try this type of numericals. Okay, and if you have any doubt, you can put it in the comments. We can discuss those doubts there, and if required, we will get a extra discussion class on that. So thank you for joining. So we'll again join in the next class with some other topics. Thank you.